All right, in this video, we're going to take a look at rotations. So make sure you have the three cutouts. There should be the cutout with the clocks. You should also have a cutout with some rules, and then a cutout with a graph of a triangle. So let's put these in your notes. We'll start off with a definition. A rotation is a turn or a spin of a figure about a point. So generally, we're going to spin our images or figures over the origin, but you can actually do a rotation over any point, and we'll look at how to do that in a later lesson. What you should have figured out from Friday was that there are two types of spins when you're rotating a figure. You can go clockwise or counterclockwise. So just remember that clockwise means you are spinning your image to the right. And then counterclockwise, you should have seen, was when you were spinning your image to the left. So if you're performing a transformation and it's a rotation, you're going to be spinning the figure either to the right, clockwise, or to the left, counterclockwise. So let's talk about some common rotations. Common numbers you're going to see when you're rotating figures are 90 degrees clockwise, 180 degrees clockwise or counterclockwise, and then 90 degrees counterclockwise. And I'm using CW for clockwise and CCW for counterclockwise. So visually, just think about what that means on a coordinate plane. So we're going to draw a couple quick examples. Let's say here that I have a coordinate plane. I'll label my x-axis and my y-axis. If I'm going to move in the clockwise direction off the x-axis, that means I'm spinning to the right. So what that means is I'm actually spinning this direction. So if I spin 90 degrees clockwise, remember what that means is that you're also doing the same motion in the counterclockwise direction. So if I start at the x-axis and I go this way, this is the same thing as a 270 degrees counterclockwise. When we look at 180 on a coordinate plane, a 180 spin clockwise is the same thing as a 180 spin counterclockwise. And then finally, if you do a 90 degrees counterclockwise spin, that's the same thing as doing a 270 clockwise. And the reason this works is that these are rotations over a circle, and so these numbers are adding up to 360. So you're finding the partner with 360 if you subtract from 360. So when you're performing transformations, especially with rotations, you're looking at these common values of rotations. So I'm just going to put a little star next to the common ones that we'll see: the 90 degrees clockwise, 180 clockwise or counterclockwise, and then 90 degrees counterclockwise. So make sure you have those in your notes, because now we're going to look at using rules to rotate a coordinate or a figure on a graph. So you should have two more cutouts to put in your notes right now. So hit pause in the video right now just to double check. I'm going to scan over to my next slide. So these are the rules for rotations. We're going to look at the common rules, and we're going to rotate this triangle RTY in three directions. So first off, let's list the coordinates for r, t, and y. R is at -8, 8. T is at -7, 1. And y is at -3, 5. So I'm going to use some different colors here. I'm going to start with red, and I'm going to do a 90-degree clockwise rotation of that image. So remember, visually what you should be imagining is that this picture should be moving to the right clockwise. So 90 degrees clockwise, I should see this shape going to the right on the coordinate plane. So using the rules, my coordinates for r prime, if you take a look, the rule for 90-degree clockwise is just taking the y value of your original point and putting it in the x coordinate, and then taking the x coordinate and switching it with the y value and switching its sign. So it sounds like a lot, but it's actually not too bad. What I'm going to do is take my original y value, and I'm going to move it to the new position. So my y value is 8, so my new y value is going to be 8, or my new x value is going to be 8, excuse me. And then my x value now is going to change its sign and go to the y position. So y prime is at 8, 8. Excuse me, for r prime. For t prime, we're going to do the same process. Take our original y value, put it as the x, take the original x value, change its sign as y. So 1, 7 for t prime. And then finally for y prime, we're going to look at switching my y value becomes my x value, and then now my x value becomes positive. We'll make sure those have prime symbols on them. 5, 3. So what we just did was transformed, and we rotated that image 90 degrees clockwise. I'm going to change colors here. We're going to look at a 180 degrees. And notice for 180, it's the same in both directions, clockwise or counterclockwise. This one's not too bad in terms of the rule, because all you do is you take the values of your x and y and you change the signs. So I think this one's a little bit easier for students to see the relationship for. So starting with our original shape, notice if you do a 180 clockwise or a 180 counterclockwise, the shape's going to end up in the same position. So my new coordinates here, I'm going to label them as different prime values. I'm going to have r double prime, -8 becomes +8, and this one becomes negative for my original coordinate. We're going to go back to the original starting point, my original pre-image up here. For t double prime, my original coordinate was -7, 1, so I become 7, -1. And my new coordinate y double prime becomes 3, -5. And we can see where this one ends up on the graph. So 8, -8, 7, -1, and 3, -5. So we just performed a 180-degree spin of our original triangle, where it's transforming and rotating to that other quadrant down there. All right, the last one we're going to look at, I'm going to do in a third color. I'll use purple. We're going to do the 90 degrees counterclockwise and see where that ends up. So again, remember with the rules, always try to envision where you see the shape going. So counterclockwise means if I'm starting originally here, I'm spinning it counterclockwise, I'm spinning it to the left. So I should see it end up in that quadrant down there. So the rules for counterclockwise, I'm going to do triple prime here. Take your original y value, make it negative, and then switch your original x value to the y's spot for the new shape. Let me zoom out so we can see our original. So my original y value was 8. That moved into the position of the x value, but I made it negative. My original x value was -8, and I moved that to the new y position. So my new coordinate here is -8, comma -8. T triple prime, my y value becomes negative, so it becomes -1, and my x value just moves into the y position, so it becomes -7. And then finally, the y coordinate, do the same rule. We're taking the y value and making it negative, and we're moving the x value into its new coordinate as the y's position. So -5, -3. And that's performing a transformation of a 90 degrees counterclockwise. And so you can always double check. You can use a coordinate plane, or excuse me, you can use patty paper, trace over this, and kind of spin it around and see if you're able to see the correct transformations of these shapes. Go ahead and try to work in your packet. See if you have any questions with these rules and how you do the transformations for rotations.